previous chapter. Okay, in the previous chapter, we discussed about visualization. Visualization is a technology that is used to share computing resources between hardware and virtual users, okay, or clients. A good example is what we use in the labs. We have our PCs and we can share the resources of the PC through visualization by creating virtual machines with VMware or with Oracle VirtualBox. However, there are other visualization technology that can be used for this purpose. For example, is Hyper-V. Hyper-V is another visualization technology by Microsoft. Today, we are going to introduce another visualization technology by Huawei, which is called FusionCompute or FC. So this chapter is a description of another hypervisor, or what we call virtual machine monitor, okay, and how it can be used to share computer resources in the cloud, meaning sharing cloud servers and cloud data center resources. So that is what this chapter is all about. So we will discuss about the architecture, the functions, the concept, functioning and planning, and the deployment of FusionCompute, or what we call FC. For me, I prefer to call it FC. It's a very good abbreviation for it, FusionCompute. So the objectives of the chapter, basically, the basic components of FusionCompute visualization will be discussed. That's the suite, what it contains, what are the things that are inside the visualization technology. Then the architecture, positioning, features of FusionCompute, the functions of FusionCompute, then planning and deployment of this technology will also be discussed in this chapter. Hopefully, we should be able to complete the chapter today. So the first section is on FusionCompute Visualization Tool, or suite. So FusionCompute is one of the leading visualization solutions out there. Walaikum salam. One of the most popular visualization technology out there includes VMware and Oracle VirtualBox. Even in CCQ, these are the ones that we use the most. But FusionCompute is another very strong candidate out there. So why or how is it used? What are the advantages of this technology? The first thing is it gives better infrastructural utilization in terms of utilization of CPU, memory, storage, and input-output devices. It gives high utilization of the resources after being visualized or after you create the virtual machines. The second one is it improves significantly in terms of the fastness of speed or service rollout. Okay, so basically when you deploy it, it's basically used, it's deployed easily and faster. A much lower power consumption. So power consumption, basically it doesn't require a lot of power, okay, when you actually want to use it. The last but not least has to do with rapid automatic fault recovery. In terms of fault recovery, it's very easy to recover from losses or crashes of virtual machines. And This happen in a way that you may not actually lose anything because virtual machines created on FC, they are actually independent of each other. Okay, so it follows the principles of isolation as one of the things we discussed in the previous chapter, in the last chapter, isolation and partitioning. So also power restoration features is there. And in terms of cost, data center cost basically is very low. Okay, so also it increases system uptime. So these are some of the many advantages of using this technology.
Powerful restoration feature in restoring data feature.
Power restoration simply means the usage of power. Okay, because if you deploy anything, it has to draw from electricity and power, okay, for it to be able to function. So basically, it has lower restoration in terms of the usage of power. So now we go to the positioning and the architecture. Fusion Compute is cloud operating system software, okay? And it functions just like any other visualization technology, so it visualizes the hardware. What are the hardware resources that can be visualized? Who can tell me, according to the last chapter that we discussed, that can be visualized? CPU, good. Operating CPU, let's take CPU.
Because they can really store, right? Information.
According to what we discussed in the previous chapter.
CPU
Memory, good.
memory.
Yes. And input-output devices, right? So they are classified into three. However, now we want to follow your suit, okay? When you said hard disk, you are still right, actually, because Fusion Compute did not consider memory and disk storage as one thing. So basically, it separated them into two, okay? So in Fusion Compute, we can have visualization of storage, network resources, okay? Yeah, and network technology. All these can be visualized, okay? Then we have also, in terms of scheduling and management of virtual resources, also, it does this in a unified interface that is called VRM. Okay, we will discuss this in the next coming slide. VRM I used. So this is the architecture. Okay, in the architecture, it has four basic functions. Aside from the fact that the hardware aspect has basic physical devices of cloud computing. Basically, these are what? Cloud facilities. So these are the cloud facilities down here. Okay. And Fusion storage block. So this is the Fusion storage block. Okay. So what do we do with the physical devices here? Okay. So it provides cabinet, power supply, uh, cabling, monitoring, cooling, firefighting, decoration, and grounding. So these are some of the things we can get from cloud facilities. That's the first section. Okay, in the second section, the Fusion Compute can provide things like Fusion Compute itself. There's also what is called Fusion Compute Pro and e-backup, and then the last one is Ultra VR. So these functions. You can see them here: 1, 2, 3, and 4. Okay. Now, in terms of what exactly this Fusion Compute can provide, it provides availability, security, scalability, visual computation, visual storage, and virtual networks. Okay, so basically these are the important things that we have in this visualization technology. Okay, so Now let's look at the general architecture, how it looks like. This is simplified architecture, if you can see on the screen. In the previous version 4, they have another architecture. I like it, so I brought it back. This is the previous architecture in version 4. It's very simple to understand also, but I'll go back to the present one. This is the present architecture. It's divided mainly into two. Okay, what is called CNA and VRM. CNA simply means compute node agent. This is similar to what you have as a VM, virtual machine. Okay, so basically you deploy on servers that need to be visualized. So basically, if you have a hardware, you can deploy a virtual machine on it, right? So also you can deploy a CNA on it in this case. So CNA are deployed on what? On server, because we are dealing with cloud, so we are not dealing with PCs. Okay, so in cloud we deal with servers. Okay, so you can deploy the CNA on servers. So just know that the CNA are deployed on servers, while the VRN, okay, they are deployed on virtual machines or on physical servers. Now, this VRM, you can have access to it through what is called web portal or web UI portal. The web portal looks just like this. Yeah, it looks just like this. Okay, so this is the interface for the web portal. You need to have access, admin, or a username and password simply. After you put in the username and password, then it will give you access to the VRM. Okay, so then you can have access to the VRM. Okay, so the VRM simply give you the interface that you can use to deploy your CNA and visualization technology. That basically to deploy your virtual machines. Okay, so you simply need to log in and then you can have access to it.
That was my question. What is the difference between the CNN and VRM? CNN, the VRM is the interface to deploy the CNN after logging in.
Okay, so the CNA is deployed on servers. That's directly on servers. Okay, but the VRM is a visualization for virtual machines or for physical servers. Okay,
On the service, you mean
physical servers.
specific.
So if you have now, if you have your data center, in your data center you will have a lot of servers. These servers, they are actually borrowed by users. Okay, so if you want to use this using Fusion Compute, you need to have access to this CNA
You need to use the services.
to use the servers.
Okay.
Servers,
Servers, not services.
not services, servers.
Servers.
Okay, you can see server 1, server 2, server 3 like this. Okay, so basically it's a deployment for the servers, while this is a deployment for virtual machines. So this is the main difference.
And first we need to deploy them on the virtual machine, the virtual resource management. Should be first deployed, log in, and then we can use the CNA.
No, you don't deploy CNA on virtual machines. You deploy them on the servers.
Then what did you say we have to first?
This is for VRM.
Yeah,
Okay,
the
so in the Fusion Compute, if you want to use the virtual machines, okay, you have to log in through this. Okay, then you can have access to the virtual machines
okay,
or physical servers.
okay.
Okay, that's where you will create the VMs. Now, let me just take you one step backward. I mean forward. That's why I say I like this old architecture. This old architecture shows the VRM as an interface. That's what you as a user will have access to. You as a user. Okay? It's just an interface. Okay? If I take you back here, this is the interface. You log in, and then you will have access to all these virtual resources through VMs. Okay, so you have access to the storage, to the network, to the processor. Okay, but now they are visualized. Okay, so you will have a portion of it as assigned to you by the cloud, or as you wish, because it's on demand facility. Okay, if you need more, they can actually scale it up for you. Okay, so basically this is what happened here. And this is, okay, this is the VM section, while this is the physical section, physical machine section. So in the physical machine, you have all the clusters of resources in the data center or in the server. So basically this is how it works. Okay, so you have the virtual machines, all the resources are visualized here in pool of resources. Okay, and they are actually taking these resources from a physical machine down here, a portion of it. So, but you as a user, when you want to use it, you only have access to this interface, okay, web interface. Once you log in, then you can see, I actually have the diagram, but I don't know why I removed it from the slides. It will show you pictorially, if you log in, what you will see. Okay, basically it will show you where you need to create a virtual machine and how you can deploy it, okay, and how you can assign the CPU resources, the memory resources, the disk resources to the virtual machine. Okay, now it gives you another one, okay? Here is, I'm supposed to ask you, because we keep mentioning it. Yes, that's why I say I'm supposed to ask you, you know? So now this is you, the user, okay? You log in and you have access to the VRM, okay? You will see all the VRM here, okay? So once you log in, you will have access to the virtual resources and to the physical resources from the PM. This is from the VM, virtual resources, okay? But then you always know that after you create your virtual machine, there's need for you to install the operating system, just like what we did in the lab. So you can install a Windows or you can install a Linux. Okay, then you can use. So these are the VMs. Okay, you can see quick VM deployment. So basically, after you log in, then you can create a virtual machine. Then you can actually install an operating system on it. Very easy, the same steps that we did in the lab.
So first login, then we have access. First to login,
Yes.
then we can have when then we install the VM.
Mhm.
And then we can access the
First login, then you create the VM. Okay, just like you log into Oracle VirtualBox.
yeah.
Okay, after you open it, then you will see create virtual machine, right? So the same, you create the virtual machine and then you can open it to install an operating system in it. Okay, so it's the same steps. So this is the main differences between CNA and VRM. You asked me in the previous two slides. So CNA are deployed on servers, okay, while VRM are basically deployed on VMs or on physical servers. So in terms of the functions, CNA is implemented on virtual computing functions, and it's used to manage the VMs running on a compute node. CNA is the compute node, actually. Also, it manages compute, storage, and network resources. These are what the CNA can manage for you. But the VRM basically manage block storage resources in a cluster, as we've seen in the previous diagram. Okay, and also it's used to manage network resources, but the network resources must be related to an IP address and virtual local area network, that's VLANs, as we have discussed in the previous chapters for networking, also can be used to manage the life cycle of virtual machine. The life cycle of virtual machine starts from creating the virtual machine, managing it, and once you are done, you can kill it. So that's the life cycle. Okay, all this can be managed from the VRM. So you can read through it. These are some of the functions. Yeah, more functions of the FC, that's the visualization technology. Number one is virtual computing, one of the main functions. So this is not different from what we discussed in the previous chapter about visualization. You can partition, you can isolate, okay, you can also do what? You can migrate virtual machines. So you have your pool of resources here. This is the physical machine, PM. Then you have your FC, which is now the hypervisor. Okay, the FC will provide this pool of resources for you. And then you can create a virtual machine on it. After you create your virtual machine on it, you can install your operating system and then you can have your applications. This is the same thing that we discussed in the previous chapter. Okay, and you can see that the virtual machines are partitioned, meaning they are isolated from each other. So meaning that if anything happened to one, it will not affect the other one. So this is the principle of visualization actually. If you create virtual machines, it means that the virtual machines are independent of each other, okay? And they follow also the principle of isolation. But then, what are the things that we can visualize on the FC? Now we already know them. In the previous chapter, we said is CPU, right? Let me take this one. Number one, CPU. We said also memory in the previous chapter. And we said input-output devices, okay? But then FC added disk. For the SC, disk is separate from memory. But in general visualization technology that we discussed in chapter 6, memory is taken as part of, disk is taken as part of memory. Okay, because of course, when we say memory, there are two types of memory. It means that there are temporary memory, which is the volatile type, like the RAM, and then we have the permanent one, which is the hard disk. Okay, so but in this case, these are separated into two. So we have the memory section, and then we have the disk section. So that's how the FC treats them. So in terms of computing, visual computing, we can visualize CPU, memory, disk, and input-output devices. Next one, number 2 is virtual storage. Virtual storage means now we have all the disks on the data center or on the server that provide all the resources. This disk can be located, because it's a distributed system, it can be located in different places. Okay, so all this disk can be unified through a SAN storage. We now know what a SAN storage is. Okay, we know the SAN protocol, DAS protocol, and NAS protocol in the previous chapter. So this is used here. The SAN protocol is used. Okay, then this can actually unify all the physical storage that we have. Then you can have your FC here. And the remaining part is the same thing like the previous one, okay? So from the FC, you can create your virtual machines and you can have access to the computer resources. That includes CPU, memory, input-output device, and storage. But here in this section, we are more interested in the storage aspect, okay? So compute or virtual storage is what we actually want to concentrate on. So basically, it uses a function in the FC that is called FusionSphere. The FusionSphere is what is used to manage the storage. So that's how it looks like. It uses SAN storage protocol, and in the FC, it uses FusionSphere. The FusionSphere is used to manage the storage that we have in the cloud. Then the network section, number 3. The network section uses a NIC if it is wireless. Okay, so you're gonna have a physical NIC. Okay, and the data center or server will need to be connected to a port. Okay, so you're gonna have a port just like a switch port or a router port. Okay, so this router port or switch port, you need to create VLANs on it. Okay, so you're gonna have your VLANs. That's why we revised VLANs in the previous chapters. Okay, so after the VLANs, these VLANs, you're gonna create the virtual machines in different VLANs. Okay, so you have like this virtual machine related to this VLAN, and it will be done through a different interface. So you can see the interfaces here. Okay, you can have many interfaces, and each interface you can create a virtual machine and associate it with it. The virtual machines can have different operating systems. There's no issue with this. We are already used to this one. Okay, so by the way, I need to mention also the switch we have here is a virtual switch. That's why it's called vSwitch port. It's a virtual switch. So you're gonna have your virtual switch. On the switch, it will have different ports where you create your VLANs. Okay, so through the ports, you create your VMs. Okay, so the VMs will have to be interfaced with the virtual switch through this interface or through these ports. So basically, this is how it looks like. You can create your VLANs, and it uses a technology called distributed virtual switches, DVS. The DVS provide independent network planes for each virtual machine. So basically, each virtual machine that you create, let's say VM1, VM2, will be in different independent planes. So meaning that whatever you do here, it will not affect the other virtual machine, not affect. Likewise, in case if anything happened to one virtual machine, it will also not affect the other one, because you can see that they are actually independent VMs that you have created. So these are the major functions. I will take you 3 steps backward, a few steps backward, let me say. So you can see what we just explained here is exactly what we have here. Okay, the compute function, the storage function, and the network function. Okay, so that's what we explained in these slides. This is the compute function, number 1, virtual compute, number 2, virtual storage, and number 3, virtual network. All these are some of the functions or benefits of using the FC. More functions include resource sharing and time-based sharing. Oh, sorry, this will be 4, and I will call this 5 rather. Time-based sharing. So resource sharing, basically sharing of resources. Of course, if we create virtual machines, they will share resources of the physical machine, PM. Okay, so if you create VM1, VM2, VM3, okay, all this will take some percentage of CPU, memory, and input-output device from the PM. Okay, so this is before visualization, or what we have as PM, and this is the VMs. So in percentage, you can see that if the physical machine has 60% of utilization of resources, the VM1 will take some portion of it, let's say 3%. VM2 will take some portion of it, and VM3 will take some portion of it. And the server will still have more percentage of resources that are left for it to run actually. Okay, so but the more you create VMs, the more VMs will actually take from this percentage. So if you create more VMs, they will take some portion of the memory, they will take some portion of the CPU and the disk and the input output device. Okay, so there is no any specific formula to calculate this. Okay, it all depends on when you create the machine, what percentage, how many gig did you assign to the VM. Even in Oracle VirtualBox, the same thing we do. After we create the virtual machine, we assign 30 gig. By default, it comes at 15. So you can increase it to 30, and you can increase also the memory. Okay, so basically it's the same thing. So before visualization, once we create more virtual machines, it helps us actually to utilize these resources more. That's the actual general idea of the cloud. Because if you have a data center that is quite big, and this data center is used by only one person, that's if it is to be used as a physical machine, as a physical server, only one person will have access to it at a time. That means that person cannot utilize all the resources in it. Maybe the person will only be able to utilize maybe 1% of huge resources. So what are you going to do with the remaining percentage of the resources that you have? It's not used. But if you create virtual machines in the cloud and all of them take from the same resources, you can see the utilization will be more, because each person will create and use different portion of the CPU, the disk, and also the input-output devices. So you have a large data center that contains a lot of servers. If it is one person that uses it through one monitor interface, the utilization is very small. So it's a waste of resources. But if you create virtual machines and anybody can use his device to log in, create a VM, and use from it, you can see all of them are using from the same pool of resources that you have in cloud data center. It means the utilization will be what? More. So this is a very good way of utilizing cloud resources. So you can see that if you create more VMs, each person will create a virtual machine and use. They are all using from the same portion of pool of resources that we have here. How about time sharing? Time sharing means if it is a physical machine with one interface, okay, one server, only one person can use at a time, right? But if it is virtual, everyone creates through his interface, create a virtual machine and use from it. They can be using it at the same time, sharing the time and sharing the same resources. This is the idea. So I don't have to wait for the user to finish, then I use. No, I can simply use my device. While he's still using, I create my own virtual machine. I also use. So we are sharing the time. Okay? So the idea of time sharing simply implies that you create different interfaces, create different virtual machines through different interfaces, and different users can actually use it at the same time. So you can see utilization can increase. Now, the idea of using it alone is that maybe if it's me and you that will be using it, I'll use it in the daytime, and you use it in the evening. Still, the utilization is less in this case. But if we create different virtual machines, you can see different VMs here created. You can see each one will take high portion of the resources and use. So this is a very good way of utilizing the resources. So in this case, we don't have to actually wait for the timing. Even at peak period, off peak period, we can actually use it. The next aspect is some of the benefits. Fault tolerance. Fault tolerance simply means you can see this is the resources that we have. Okay, these physical resources, PMs. On the PMs, we create virtual machine. For example, in this server, you create this virtual machine, and this. Okay, the same thing we have here. Now, look at this. This shows that there's a problem on this physical server. So if there's a problem on this physical server, is it going to affect the virtual machines that you created on it? The answer is no, because you can migrate the virtual machine, okay, to the next physical machine, and then you just need to restart it using what is called HE. Once you restart it, the content of the virtual machine you create will still work, and you restore it back automatically. So you just simply need to restart it, and once you restart it, basically it will work. But it's now moved from this physical machine that has problem to another physical machine. This through migration. Also, migration is used here. Let me see it. As you can see the word migrated. So that's the concept of faults. The concept of fault simply means if one physical machine has problem, you can migrate the VM, okay, to the next physical machine and restart the VM. Once you restart the VM, all the content of the virtual machine will still be okay. Okay, so you are not going to lose anything. So that's the resilience of the FC, because this also happens in Oracle VirtualBox. This also happens in VMware. You can always migrate a VM that you have created. If the machine has problem, you can migrate it, and then you need to restart the virtual machine. All your configurations, your program that you have done, it will still going to be there, okay? So it's not going to be lost. In terms of maintenance also, if you want to do maintenance, okay, for example, you want to maintain this, if this is 1, 2, and 3, if you want to maintain this, so you can migrate all the virtual machines in it, okay, then you can do your maintenance. Once you finish, you can re-migrate the virtual machines back to it. Okay, so basically, if you want to do maintenance, so it's very good for fault tolerance and also for maintenance. So maintenance, basically, it doesn't mean that the virtual machine have problem. No, you want to do some maintenance, you can simply migrate it, the virtual machines, and then once you finish maintenance of the physical machine, you can bring the virtual machine back and restart it. And all your configurations, your content that you have created there will still be there. Okay, so this is basically the idea. Yeah, so that takes us to the last part, which is installation. Installation is very easy. To do installation, this is the minimum requirement. If you want to install an FC, that's FusionCompute, you need a laptop or a desktop. That's all. Okay, this laptop should have some space, like 8 gig space. Okay, shouldn't be filled up. Some space need to be there. Okay, also you need to have an operating system, Windows 10, 11, sorry, 7. All these are okay. If it is server, Windows Server 2008 will work, 2012 will work, or any latest version. The CNA, okay, for server support also is required. So you need to install the CNA. And these are some of the precautions that you need to do. Otherwise, after you complete, it will not work. Okay, do not change the local PC's IP address. So don't change the IP address, maintain the same IP. Disable the firewalls. If you have some firewalls, sometimes it blocks the installation. So you need to disable the firewalls. I don't know if we can trust them to that level, but you need to disable the firewall because maybe it will block the installation, okay? In terms of the characters in the path, if you write the names of the files, don't exceed 256 characters, and do not restart if not required during the installation process. So you have to this is just to tell you it's not very important. This one is just to tell you how to install the FC, okay? So this is the process. First of all, you need to install the host. Of course, the host is the PM. Okay, you need to install the host, then you install the virtual machine through VRM. Okay, so this one is for the VRMs. You don't have this slide? You have it. You have this one.
Yes, behind the picture.
It's behind. It's on the same slide. It's okay. It's not an important slide. It's not an important slide, so don't worry. Just install the host, then you install the VRM on it. Basically, this is what we want to show. Okay, I got this from the FC, from the interface. Okay, they will tell you need to install the host, then you install the VRM. In the VRM, you can customize it or you can make it to be a typical installation. So they have these two options. Okay, so once you install, that's it. So yeah, this give more explanation about the host and the VRM. Okay, the host is deployed on the servers, while the VRM is deployed on VMs or physical servers. This one we already know based on what they explained in the previous chapter. Okay, and then this is the deployment principles. Views. What? Different solutions?
Yeah.
No, this is just installation process. Installation process, okay? It's not that important, but we need to know it anyway. So basically you have different servers, okay? On the servers you have your CNA because it's a physical server, okay? So you have your CNA here, okay? Then you have your virtual machines. Now, the virtual machines are of two types. The VRM are of two types. That's what we call active VRM, the one you are using currently, and standby VRM. The standby URM is not used until when required. Okay, so there are two types of VRM. So this VRM is basically the interface that you will use to manage the VMs that you create. You remember this? I need to go back again. The VRM interface. This is it. Okay. You log in through the VRM interface. After you have logged in, then you can have access to be able to create the virtual machines. So the same thing is shown there, okay? So you log in through the VRM, active VRM, then you can create your virtual machines. Okay, the virtual machines will relate to the CNA and to the server. Of course, they are sharing from the portion of the server. If it is a standby VRM, meaning that it's not used until when it's necessary. Basically, this is something like a backup, more or less. Okay, that's why it's called standby. The same diagram is shown here, except that now the active VRM and the standby VRM, they are deployed on the second cluster. Okay, so they are deployed on the second cluster, then you can create your virtual machines. And then the virtual machines interact with the CNA, which in turn interacts with the server because it's sharing from it. Yeah, so that's the last slide. So this shows the VRM nodes being deployed on a physical server. I think I have a group that will explain this chapter again, right?
I think that's with Fusion Access.
Fusion Access is different. Another one, but similar.
With three.
Yes. Any question? Who is there? Makbola and your friend. Any question? Who is there? I can't see your face. No. Any question? Okay, I have a question for you. The question says, which products are included in the Fusion Compute Visualization Suite? A. Fusion Compute, Fusion Compute Pro, eBackup, Ultra VR. I'm asking Makbola and Noor. Which is the correct answer? I want to know if you are with me. eBackup, eBackup, this one? Correct. And what? This one? This one and this one. All of them are correct, actually. All of them are correct. So you need to go back 2 steps backward, few steps backward, and you can see the slides. This is the slide, okay? Fusion Compute Pro, eBackup, and Ultra VR. Now let's go to the second question, to the class. What are the benefits of Fusion Compute? Benefits. Number 1, enhanced resource utilization. Agree?
Yes.
Improve system availability.
Yes.
Low TCO.
Yes. What is TCO time?
No, you're supposed to tell me.
Total cost of ownership.
Yes, total cost of ownership. Actually, all cloud services have this TCO. If you remember, it's the general benefit of cloud, right? However, did they call it TCO here? No, but they talk about low cost.
Yeah.
Okay, so let's take back. Maybe we have to look at it also in relation to the other ones.
Lower data center cost.
They talk about low cost. Where is it? Yeah, lower data center costs. So lower data center costs. Maybe yes.
Also,
Green and energy saving.
yes, because it's reduces the consumption of energy.
Power.
Yeah.
Power.